in the whole wide world. So this is basically our factoring refresher. You guys did a lot of factoring in Algebra 1 and you spent a good amount of time doing all of this stuff. We are not going to spend a good amount of time doing it this time because it is a refresher. But we are going to go slow enough in that we're going to take 2 class periods to go through it. The first thing we're going to talk about is the greatest common factor. The greatest common factor you'll often see represented as the GCF, baby. And it means what is the biggest thing that we can pull out of each component. For the most part, we are going to be dealing with what we call trinomials, which are expressions that have 3 terms. But for starters, with the greatest common factor, we'll do a 2 term just to get us started. So if I have, for example, 12k minus 18, and I ask you, well, what is the greatest common factor? What it means is, what can I pull out of each component, right? Each term. I know, Jeremiah, I appreciate that. You're on it. You know what you're talking about, right? We're going to look at this term and this term, and we're going to say, what is the biggest thing that we can pull out of it? What is the biggest thing that we could divide it by? You were right, Jeremiah, the first time. So we're going to look at it. We're going to go, well, yeah, we can look at this and go, definitely they're both divisible by 2, right? Each term is divisible by 2. 3, let's look at 3. Yeah, they're both divisible by 3. 12 divided by 3 is 4. 18 divided by 3 is 6. But they're also both divisible by 6. And in this case, that's going to be the biggest common factor, right? Because I don't have any other factors for 12 besides 12 itself, right? 1 times 2 is 12. 2 times 6 is 12. 3 times 4 is 12. Those are all my factors, right? If I looked at the fact, well, let's look at it. Let's go in this. If I have talk about my factors of 12, I have 1 and 12. I have 2 and 6, and I have 3 and 4. Right? If I look at my factors of 18, I have 1 times 18. I have 2 times 9. I have 3 times 6. 4, 5, 6. That's it. Those are all of my factors. So we're going to look at these and go, well, what is the biggest number they have in common? And it would be 6. More often than not, you're going to be able to do this in your head, right? So what I can pull out of each of these is 6. This one has a k, but this one doesn't, so I can't factor a k out. So all I can do is divide it by 6. And I look at this and I go, well, 12 divided by 6 is 2. So here I'm going to be left with 2k. Negative 18 divided by 6 is 3. And this is going to be my factored form of this. I can't break this 2k minus 3 down anymore, right? 2 doesn't have any factors other than 1 and 2. 3 doesn't have any factors other than 1 and 3. This isn't a trinomial, but we're getting to the trinomials, Jeremiah. I just wanted to lead with something that was a little shorter to start. So let's look at another example. And this time, it'll still not be a trinomial because I want to leave Jeremiah wanting for more. What if I have, say, 40x squared y plus 64 x to the 4th y? The first thing I'm going to look at is what numbers I can factor out. What are my biggest numbers? What is the biggest thing that is divisible that I can divide out of 40 and 64? You're right, they are 2, but also they're each divisible by 4, but also they're each divisible by 8. 8 times 5 is 40. 8 times 8 is 64. If you don't know, you can break them down over here and find all of their factors, right? Or you can start with 2 and see what's left. If then they're divisible again by something else, you're going to try that. But I'm going to go right ahead and tell you that right now they're both divisible by 16. They aren't 40 is not divisible by 16. 64 is, but 40 is not. And they both have to be divisible by it. 8 is the biggest thing that they're both divisible by. And you could do it. You could like list the factors, right? I go 40. I got 1 times 40. I've got 2 times 20. 3 doesn't work. I've got 4 times 10. I've got 5 times 8. 6, no. 7, no. The next number would be 8, and we've already got that. Then we could look at 64. And we do 1 times 64, 2 times 32, 3 times 16, 4 times, what is 4 times, or is it 4 times 16? It's 3 times 18. Sorry, 3 times 18. 4 times 16. 5 doesn't work. 6 doesn't go in. 7 doesn't go in. 8 times 8. And now I've eliminated all of my possible other factors, right? The biggest number that they have in common is 8. Right? Ooh, part of my 8 disappeared. Right? And so that is the biggest thing we can pull out. But now we also have X values and we have Y values, and they both have that, right? So this one has 2 X's and this one has 4 X's, right? Here we have 2 X's. Here we have 4 X's. If everything has an X component, I can pull out as many as the least one has, right? So if this one has 2 and this one has 4, I can pull out 2 X's, X squared. They each have a Y component. It's the same one, so I could pull out 1 Y, right? And if we factor those out, we have to look at what's left. So 40 divided by 8 is 5. Here I pulled out 2 X's, right? And I only had 2 X's, so I have none left. Here I pulled out 1 Y, and I already had 1 Y, so I have none left, right? So we're going to move on to 64. 64 divided by 8 is 8. I had 4 X's. I pulled out 2, so I am left with 2 X's. I had 1 Y. I pulled out 1 Y. That is all the Y's I have left, right? I have no Y's left. How can you tell if you're right? Well, we factored it. It's just we're pulling out things that we divided out. If we multiplied it back in, we would wind up with the same result, right? This is our solution, right? We pulled out our greatest common factor. This is our solution. If I wanted to check that solution, all I would have to do is a little bit of multiplication. I would go, well, this times 5 gives me 40x squared y. This times 8x gives me plus 8 times 8 is 64. X squared times x squared is x to the 4th times y. So if I multiply it through, I should get the same thing back. So you can always check your answers. Am I going to require you to check your answers? No. But you can. If you're confused, if you're worried about whether or not you got it right, you can always check your solutions. Let's do another one of these. What if I have I don't want to do 3. I want to do example. Let's use a different color so we could tell we're working on a different problem. What if I have 14x m to the 6 minus 35m cubed minus 7m squared. This one's for Jeremiah because he's been ready. He's wanted these trinomials. I wanted to make sure he got one. Trinomial, right? We have one term, two terms, three terms. That's what makes it a trinomial because tri means three. Just like tricycle has three wheels, right? The first thing we're going to do, we're going to look at the numbers. Every number is only divisible by what? Do they have in common? Well, I've got this 7. The only thing that 7 is divisible by is 1 and 7, right? But 35 is divisible by 7 and 14 is divisible by 7. So we're going to start by pulling out a 7. Each one of them has an m component, right? This one has 6 m's, this one has 3 m's, and this one has 2 m's, which means I can pull 2 m's out. I can only pull out the number that the least one has. So we can take out an m squared. And now we're going to look at it. We're going to, well, 14 divided by 7 is 2. I had 6 m's. I took 2 out. I have 4 left. Minus 35 divided by 7 is 5. Here I had 3 m's. I took 2 out, so I have 1 left. Minus 7, well, 7 divided by 7 is just 1, right? M squared divided by m squared is just 1. So we're left with 1 right here. Does that make sense to you before I get a little more complex? This is just the greatest common factor portion, right? What if I have more than one variable? Ooh, things are getting crazy, crazy cool. I get a little nerdy when it comes to math. I'm like cool in real life. Not really. Once, maybe, back in the day. So what if I have 3ab squared minus 5? Ooh, that is not a 5. That doesn't look anything like a 5. Minus 5a squared b plus 8ab. A lot going on here, right? Did you want to know how you would check? Oh, you figured it out? Okay. Here, if we look at the numbers, we've got 3, 5, and 8. 3 and 5 are prime. The only thing they're divisible by is 1 and 5. And neither 1 and 5 and 1 and 3, right? They're only divisible by themselves. And 8 is not divisible by 3 or 5. So we can't factor anything out in terms of our numbers, right? But every single piece here has an A component. They have at least one A and at least one B, right? So that's where we're going to look at our factoring. Here I have one A, right? Here I have 2 A's and here I have 1 A. So I can factor out one of my A's. Here I have 2 B's. Here I have 1 and here I have 1. So I can factor out one of the B's. So I'm going to have 3. I had 1A, I took it out, so I don't have any left. I had 2 B's, I took 1 out, so I'm left with 1. Minus 5. Here I had 2 A's, I took 1 out, so I have 1 left. I only had 1 B and I took it out, so I don't have any left. Plus 8AB, well, I took out an A and a B, so I don't have any left there. That is my solution. This is the answer, right? We put a box around it. If I wanted to check it, I could multiply it through. I'm going to put the box around it before I multiply it through. 3 AB times 3 is 3 A B times B squared, right? If I do that part. If I do this part, I've got negative 5. A times A is A squared. B times negative 5A is B. Same thing here. If I multiply this through, I wind up with plus 8AB, which takes us back to our original equation. If it didn't, then I'd mess something up in there. Does that make some sense to you? I know you guys have seen it before, but I know it's been a while. That's a truck backing up. I'm like, please don't tell me like another lockdown. What's going on? We had a shelter in place type of thing last period because of, I guess, there was police action in the area, police activity in the area. I don't know. There's no tea. I have no idea what was happening. It's just for 20 minutes. I taught with my door locked. It wasn't even a lockdown. It was just a shelter in place so that kids weren't walking around campus while there was police activity. And then like 20 minutes later, they're like, yeah, everybody can go back to normal. So anytime you're factoring anything, you're always looking for that greatest common factor first. Always, because it makes your numbers smaller to deal with when you can. Now we're going to talk more about factoring trinomials. Now, a trinomial is any nomial, a number expression, with three terms. But we are going to be talking about trinomials of the form ax squared plus bx plus c. Specifically today, we're going to be talking about where a equals 1. Tomorrow, when I see you later this week, we're going to talk about what to do when a doesn't equal 1. I always like to start this off with a chart when we're factoring trinomials. If I have ax squared plus, you know what, let's not even write it that way. Let's write it as x squared, right? Because we want our a to be 1, so we wouldn't write it, plus bx plus c. I know that my factors are both going to be positive. I'm going to wind up with an x plus something times an x plus something else. If I have a factor that's x squared minus bx plus c, I am going to wind up with factors that look like x minus something times x minus something else, right? I'm going to just put question marks in here because we don't know what the factors are yet, right? I just know that they'll both be negative factors, right? Here I know that they'll both be positive factors. If I have x squared plus bx minus c, I'm going to have a factor that's x plus something times x minus something. The bigger factor will be positive. So what if I say, I don't know, this one would be the bigger factor, right? If I have x squared minus bx minus c, I'm still going to have an x plus something times an x minus something, but this factor will be bigger, right? So notice when we have a negative c term, our bigger factor depends on what our b is, right? The way we find those factors is what we're looking for are the factors of our c term that add to our B term. Factors of C term that add to our B term. What does that mean? Well, I'm going to show you what that means. I'm going to keep this chart right here. I love this chart because it really helps when you're factoring. If I have, for example, x squared plus 14x plus 45. Everything here is positive. So I know that my factors are going to be something x plus something times x plus something else, right? The way I am going to find it is I'm going to find the factors of my C term, right? This is my C term that add up to whatever I have for B. So I need to find the factors of 45 that add to 14. So if we look at 45, and I did my factors, I go, well, I have 1 times 45. I have 2 doesn't work. 3 doesn't work. 3 does work. 3 times 15. 4 doesn't work. 5 times 9. 6 and 7 don't work. 8 doesn't work. But 9 we already have. So we've listed all of our factors of 45. So we're going to look at those and go, well, if I have 1 plus 45, that equals 46. That is not 14, right? If I have 3 plus 15, that's going to equal 18. 18 is not 14. 5 plus 9 equals 14, right? These are my factors. 1 can go here and 1 can go here. Again, we can check these, right? When we say we're factoring something, we're saying that if I multiply one of these things times the other, I should get back what I broke down, right? And the way we do that with trinomials, you might remember, is we use something called FOIL. I hate the expression FOIL because it only works for these trinomials, the binomial pieces. But ultimately what we're doing is we're multiplying through. We would take x and we would multiply it times each of these pieces. X times x is x squared. X times 9 is plus 9x. Then we do it with this piece. X times 5 is 5x. 5 times 9 is 45. Notice that the last thing we always do are these two numbers on the end, which is why if this is positive, both of these have to be positive or both of them have to be negative. Otherwise, we can't get a positive out in the end, right? And then we would just combine our like terms. X squared, 9 plus 5 is 14. And we wind up with the original equation. So when we factor, if we multiplied them back together, we better get the same equation because all we did when we factored was divide, right? So when we multiply them back, we should come up with the same solution. In this case, though, our solution is this x plus 5 times x plus 9. These are our factors. Factors in quadratics are really important because if we set them equal to 0, we can find our solutions, which we will go over next week. For this week, we're just talking about factoring in general. So let's look at some more of these. What if I had x squared minus 15x plus 26? If you look at our chart, we have a positive C term and a negative B term. And if you look at our chart, that's the second thing here. So you know all our factors are going to be negative. I'm going to have an x minus something times an x minus something else. Otherwise, everything's going to be the same. I'm going to take my factors of 26. that add up to negative 15, right? So all our factors are going to be negative. So if I have negative 1 times negative 26, negative 2 times negative 13, dang, those are all the factors of 26 that I have. But if I add them together, if I add these two together, I wind up with negative 27. If I add these two together, I wind up with negative 15, which is what I was looking for. So these are the factors that we're going to use. And in here, we're just going to go ahead and put in 2 and 15. This is our solution. These are our factors. This is what it breaks down to. That's what we're looking for. Does that make some sense to you? Let's look at one that doesn't have a positive C term. Let's look at k squared plus 2k. I want 2k. Somebody give me $2,000 right now. Minus 48. Right? We know by this negative C term that one of our factors is going to be k plus something, and our other factor is going to be k minus something. Because at the end, when I would multiply these two terms together, the only way I could end up with something negative is if one of them's negative. If they're both negative, I get a positive. If they're both positives, I get a positive. The only way I can have a negative C term, the only way this negative 48 can exist is if I multiply something times a negative number, right? If when I multiply these back through, I have one negative. Otherwise, everything's going to be positive, right? So we are going to take our factors of negative 48, and we are going to determine which gets the bigger factor, the positive or the negative, by the sign of our B term, by what is in front here. This one is positive, which means that our bigger factor is positive and our smaller factor is negative. So we would have negative 1 times 48. We would have negative 2 times 24. We would have negative 3 times 16. We would have negative 4 times 12, negative 6 times 8. 7 doesn't go in, so our next factor is 8, and it's already represented, so we know we're done, right? And we need to look at these now and go, well, which ones of these add up to 2? Positive 2. These add up to 47, right? These two add up to 22. These two add up to 13. These two add up to 8. And these two add up to 2. So these are the ones that I want, right? The ones I'm going to use, the negative's going to go where the negative is. The positive's going to go where the positive is. This is our solution. If we want to check it, absolutely we can. We would go k times k is k squared. K times negative 6 is negative 6k. 8 times k is 8k. 8 times negative 6 is negative 48. And then when we combine our like terms, we wind up with k squared plus 2k minus 48. Right? So we know we're right because we got back that same thing. So our solution for sure is this. Again, I'm not going to ask you to check them. I just want you to kind of understand how they work when you look at them. I'm going to do one more where we have to factor something out before we get started. And then I'll be done with you. That's it. I'll be done with you. It's right in gold because, it's the best problem of the day because it's the last problem of the day. And so it seems only right that we should write it in gold. So let's look at this. What if we have 5z minus 25z? My z's always have a line in them so that you can tell them from my 2's, plus 30. When I look at this example, notice we don't have an a as our x term. And we won't always, and we'll go into how to deal with those later if they're not a common factor. But for today, for the sake of today, each of them are divisible by 5. So we can start by pulling out a 5, right? 5z divided by 5 is just z. Minus 25 divided by 5, well, that's 5z. Plus 30 divided by 5 is just 6. Now, we don't want to lose sight of this 5, but we're kind of done with it. We just kind of need to make sure that it follows our answer all the way down, right? So here I have a negative term and here I have a positive term. And if you remember, that's going to give me an x minus something times an x minus something else, right? And if you don't remember that, you can go back and look at the chart. So we are going to find our factors of 30. Oh, sorry. No, we're not. We're going to find our factors of 6 that add up to 5, right? All our factors are negative at this point. So we would have negative 1 times negative 6. We would have negative 2 times negative 3. When I add these together, I get negative 7. When I add these together, I get negative 5. And that is what I'm looking for, which is good because these are the only factors that are available for 6, right? And so we could just put in 2 and 3. Right? So look for a greatest common factor first. It makes your life easier, right? Any questions about that? I'm not going to take it to where a doesn't equal 1 until the next time I see you because this is as far as I got with my other class and I don't want to push you guys any further than that. Technically, I'm not even going to assign you the worksheet yet because I'm not going to ask you to do the whole worksheet until I finish later this week with when a doesn't equal 1, and we're going to go over something called difference of squares. So this is all I have for you. Technically, your homework isn't even homework yet, but you can look at it. You can do the first, hold on, let me stop the video and I'll go check and see how many problems you can get started on if you want.